Let's continue with continuity and differentiability. Now, let me say about this chapter. Continuity and differentiability is one of those chapters in which direct questions are not asked, that it is continuous or differentiable. Some twist is there. So I'm just going to tell you about what twists can be there in the paper and how can you approach to them and how can you not be wrong. So first of all, first line for this, the function about continuity. Any function, the function f, any function f is said to be continuous at, let's say, x is equals to k if and only if limit x tending to k is fx is equals to f of k, or equivalently limit h tending to 0. Fine, limit h tending to 0. I'm not writing, I'm not good at writing limit as lim or lt. I just write it like this, so there should not be any confusion regarding this. So f of k plus h, that will be f of k. I'm sorry, this is c plus h. This is x plus h actually. So if you can do this, that f of x can be replaced with x plus h, then h should be tending to 0. In that case, it will be f of x, and this gives f of k. So a function f is continuous at x is equals to k if it gives the value of f of k. Fine. Now this is at a point k. If it has to be continuous in an interval, that let's say the function is said to be continuous on an open interval a to b if it is continuous at each point of a to b. That means, let's say we have this graph. This is continuous if this is a and this is b. This is also continuous if this is a and this is b. But this is not continuous if this is a and this is b, because it is breaking at some point. At this point c, it may get a value of this and not get a value of this. So it is not continuous because f of c minus is not equals to c plus. So f of c is not constant. So at a point c it is not continuous. So the function is not said to be continuous in an open interval a to b. So I will give you 3 conditions you can apply for a function to be continuous. So if it is said to be continuous on a closed interval a to b, for continuity in a closed interval a to b, f should be continuous at each point in a to b open interval. Then the second condition is limit x tending to a plus f of x, that should be f of a. This is the right hand side limit, or you can say continuity, right hand side limit continuity at a. Fine, because a plus we are going to a plus, just like in this case we are going to c plus. So limit x tending to a minus f of x is also f of a. This is f of b, let's say, because we are talking about the a to b interval, we are not talking about a point. So x tending to b minus f of x should be f of b. Okay, this is said to be left hand side continuity. At b, Okay, let me show it to you using a graph, a colored pen. Let's say this is A, this is B. Value of function at A is this, and the function is starting from here. Okay, and the value of at B is this, but the function is ending here. So f of A is not equals to the right hand side limit, that is limit x tending to A plus f of x. That value will be this, something close to A but not equals to this. Okay, these has some difference. This is not equals to, so this is not continuous. But if A and B are like this, A is this and B is this, then A will have some close to A and B will have close to B. So these values will not have any difference, but these values have no difference. But these two values will have a much bigger difference. So this is how we judge the continuity between an open interval, between a closed interval. Now I am going to tell you 4 points which are very important with respect to differentiability. That will cover your whole differentiability. If you know these points, then you can do any question. So first is, if f is even, f dash is odd. Differentiability has been covered in differentiation, of course. So the main points about differentiability is that it should be first of all continuous. So you have to check the continuity of a function. If it is not continuous, then it will not be a differentiable function. So if f is even, f dash is odd. Example, x cube. X cube is odd, so let's say it is x4. F is x to the power 4. Then the f dash will be x cube, or you can say 4x cube, but the constant doesn't matter. So this is the first one. Then if f is odd, then f dash is even. Again, x cube, you can take this as x cube, then this will be x square, 3x square. This is an even function. Then you have f is periodic. If f is periodic, then with let's say period t, then f dash is also periodic with t, with period t. Okay, this is also one of the most important properties. Example can be taken as sin x. Sin x, the period is 2 pi. The f dash is cos x, which has also the period of 2 pi. So the period remains same. The last point about this is, if f is antiperiodic, then let's say with antiperiod p, with antiperiod p, then f dash is, then so is f dash. So f dash is also antiperiodic with p. So these are 4 most important properties. Let me remind you of the formula used in differentiation. That is, f dash x is equals to f of x plus h, limit h tending to 0, minus f of x upon h. This is the most important formula of the differentiability. So if you are asked that the function is differentiable or not, first of all make the graph. You will just understand that that this is not differentiable at this point. Again, not differentiable if it is not continuous. Fine. Again, if you have this curve, then this is differentiable at this point. But if you have something like this and then this, you understand, the value is not given, the value is here, then of course it is not continuous, so it will be not differentiable. So if something is continuous, does not define that it must be differentiable, but if it is differentiable, then it must be continuous at that point. So if you have to check differentiability, first of all check continuous. If it is continuous, then only go to the differentiable condition, otherwise not. If it is not continuous, then it will not be differentiable. This was all about continuity and differentiability. We'll start with the straight lines.